today we're going to continue our work with exponents, but today we're going to start to look at integer exponents. And we'll talk about what integer means. And then then don't shut it all the way. Actually, Derek, just press the little thing on the inner. I did that for the fire drill we had. Yeah, okay, thanks. Okay, and I just wanted to mention that on Friday, this Friday, all teachers are required to post what we call progress reports. And so, as you know, in this class, we don't give D's in this class. So if you have a 70 or below, even though a 70 is passing, at this point, I would probably send a progress report on you just because you're close. Below a 70 is an F in this class, okay? So it doesn't mean anything other than I might write things like see a tutor periodically or go to the studio, see me for help. But some people, if they haven't been coming to class and they've missed some exams or quizzes, I might say to officially withdraw from the course. So you will get one of these, your advisor gets one of these, but it would be great if you wanted to talk with me about it, or if you're at all concerned that you may be getting a progress report and you just want to check with me before Friday, that's fine as well. Okay, so these are required for all your classes. Okay, so you'll only be, it's funny, it's called progress report, but you will only get it if you're not making the progress that you hope to make in a class or your teacher hopes. If you're not progressing at the point where, okay. What else is coming up? Just a little bit in advance, November 6th is a Tuesday. It's a big day for our country, and it's a big day for you because it's advising day at GCC. And what that means is all day classes are canceled on that day, and depending on what area you're interested in studying, you might have some type of group kind of presentation by, say, one of the business programs or engineering. But most of us are just here for that day to see our advisees who want to come in. And the nice thing about that is you get like first pick at classes so that you don't have to worry about the classes that you want being, taken up because you've waited to the last minute. Now, the other thing you should know is even though you're registering early doesn't mean you have to pay early. The payment deadline is exactly the same. Caitlin? Yeah. November 6th. Anybody got any questions on that? Okay. And if you have any question about who your advisor is and you can't figure it out, see me and I'll help you find who your advisor is. Okay. So I just found out by looking at my roster over the weekend that 2 people in this class are my advisees. So that was kind of a nice surprise for me. Hope it's a nice surprise for them. Anyway. Okay. So we're going to talk about integer exponents. Could anybody tell me what an integer is? Or if I drew a number line? A number on a number line. Almost. So let's say I draw a number line here in both directions here. So okay, let me put, if I say a number on a number line and I set the number -1/2, would that be an integer? Nope. No. That's any whole number, so we're close. Any whole number would be what number? 0, 1, 2, 3, 4, 5, right? Yeah. And so that's called the whole numbers. It's not called integers. So these numbers are called whole numbers. So we're almost there to get to the integers. So what do you think we have to do to be the integers? Draw more lines. In what direction? No, we could keep going like that. Yeah, but then we're getting into what's called rational numbers. Those are like our fractions or irrational numbers. So originally, Derek said any number on the number line, that's called a real number. Okay, any number on the number line is a real number. But we're interested in integers. Does anybody know what that means, integers? We got part of them up there, 0, 1, 2, 3, 4, 5, 6, 7, 8. Any guesses? Huh? If they were positive, then these would be satisfactory. 1, 2, 3, 4, 5, 6, 7, 8. Each one of these numbers has an opposite, doesn't it? 1 has an opposite called -1. 2 has an opposite called -2. -3, -4, right? 0 has an opposite as well. It's the only number that has itself for its opposite. The opposite of 0 is 0. Okay? So it's the whole numbers plus all their opposites. This is the set of integers. Okay, so this is what an integer is. Okay, so today we're going to start looking at exponents that up to today we were looking at numbers like 0, 1, 2, 3, 4, 5. Today we're going to start throwing in exponents that could be -2 or -3 or -4. So we're going to be looking at the opposites as well as whole numbers. Okay, those are make the integers. Yep. Okay. Okay, so that's just so we know what the heck integer exponents are, right? We have to make sure we understand the title of what we're doing. 0 is an integer as well, yes. Okay, so now let's see if we can read this first part of today's exercise. What do you remember about reciprocals? What do you remember about reciprocals? Someone want to tell me what they remember? Reciprocals. Opposite fraction. Almost, not quite. You're thinking about perpendicular lines and slopes, not just regular old reciprocals. That's not opposite when you do that. Opposite has to do with changing the sign. What's he doing? He's flipping it, right? Or inverting it. So if you have a fraction, so if you have something of this form, what is the reciprocal of A over B? B over A. Now remember, every number has a reciprocal, except for 0, because you can't flip 0 over and you can't divide by 0. So you can have a whole number in this form, A divided by B. You would just say 2 divided by 1, or 4 divided by 2. That all says the same thing as 2. Okay? So reciprocals. What do you remember about the special relationship that exists between a number and its reciprocal? What's the special? Yep, John? Yeah, when you multiply a number by its reciprocal, you get the number 1, which is a very important number in mathematics. So if you had 2/3 and you multiplied it by its reciprocal, 3/2, you get 2 times 3 divided by 3 times 2, which is 6 over 6, which is 1. Any number times its reciprocal is 1. That is an incredibly important relationship because it helps you to divide fractions and it helps you to do a lot of things. It brings you back to 1. Okay, so that's the special relationship. Now, how are reciprocals used in the division of fractions? So let's suppose I have or any division problem, actually. It doesn't have to just be fractions. I could have 4 divided by 2, but we don't normally use it when we divide by whole numbers. So let's take a look at something like this, 4 divided by 1/2. These two things are not the same. They're very different. Here you're dividing by the whole number 2. Here you're dividing by the fraction 1/2. How are reciprocals used here? Does anybody know for division when you're dividing by a fraction? Michael? You multiply by the denominator, so I would be 4 times a half. Just that, well, what if I was doing this? So I still, yeah, it's different then. Okay. So we want to try to come up with a general rule that works no matter what the numerator and denominator is. You multiply by the reciprocal of what? And this, if we were doing this problem, we'd multiply by the reciprocal of the denominator, which is 2/5. Let's take a look at this one. What is this one? 2, the reciprocal of 1/2. So 4 divided by a half is the same as 4 times 2, which is 8. How do you check your answer to a division problem? Any division problem. You multiply, what do I multiply? This is arithmetic, folks, right? We can be golden algebra stars, but when it comes to arithmetic, it's really scary. I want to know how you check this division problem to see if this division problem is right. How do you check it? How do you check any division problem? Do any division problem in your head. What do you multiply? Let's be specific. You take your answer, you multiply it by what you divided by, and you better come back with where you started. Half of 8 is 4. Okay? All right. So let's talk about this for a minute. 4 divided by a half, what does it mean? You have 4 units. And you're asking how many halves are there in 4 whole units? How many halves in each one? How many halves in each one of those? 2. Voila, there are 2 halves in 1 whole. That's how reciprocals work. There are 2 in each one. So how many of these do I have? How many whole units do I have? I have 8 halves. How many whole units? 4. So if I have 2 in each one, I have 2 plus 2 plus 2 plus 2 halves, which is 8 of them. I have 4 times 2. So the beauty of the reciprocal is that this tells you how many halves are in 1 whole unit. And since you have 4 whole units, you have 2 times 4. That's how reciprocals work. They're a beautiful little thing. I used to get very excited about reciprocals when I taught Math 090. So excited, you know, it's like I could barely contain myself. Any division problem works this way, not just fractions. As I said, you wouldn't do it when you had whole numbers, but if you had 4 divided by the number 2, you could say 4 times a half. Because this is like saying take half of 2, right? When you divide 4 by 2, we often use that language, take half of 4, right? But we don't usually do a division problem with whole numbers by converting your denominator to multiplication by the reciprocal, but you could say half of 4 is 2, and the answer there is 2 because 2 times 2 is 4. So it's not just division by fractions, any division problem. So what about this division problem? 4 divided by 5 halves. What would the answer be there? 4 times what? 4 times 2/5. You take the reciprocal, and then you multiply straight across. Because what's sitting under 4 here, or what 4 is being divided by is 1. So you have 8/5, which is 1.6, or 1 3/5, however you want to write it. Okay, that's division with fractions. Now, what the heck does this have to do with exponents? Well, we'll see in hopefully the relationship in about 10 minutes. So let's take a look at the next page. Okay, so the most important thing that you need to know is that all of those exponent properties you saw on the page, the first page of lecture 19, notice they didn't say the exponents were positive or negative numbers or even whole numbers. They apply to any number. Okay, so it doesn't change. So what is a negative exponent and how is it related to its positive counterpart? That's the question of the hour. That's what we're going to be focusing on, is this question right here. What is a negative exponent and how is it related to its positive counterpart? So in other words, if I were looking at this thing and I wanted to know how it compares or how it's different, however you want to think of it, how it compares or how it's different from its positive counterpart. In other words, if I had a positive 4 there, what happens when I have a negative 4 there? Okay, what happens to our problem? So that's where we're going to start today. So let's start with the definition of a negative exponent. So here we're assuming b is a counting number. So n is a counting number. So it's like 1, 2, 3, 4, 5, 6, 7, 8, all the way out to infinity. So when I put a negative sign in front of a counting number, I get a negative number. So b to the negative n is the same thing as saying 1 over b to the positive n. So b to the negative n is the reciprocal of b to the n. That's the relationship to this word reciprocal. So when you see anything to a negative power, you say, oh, if I just take that thing to the positive power, then I'm the reciprocal of that. So I do 1 divided by that thing to the positive power. They're just another way of writing reciprocals. Instead of inverting the fraction to make a reciprocal, we're not in fraction land, we're in exponent land. So to make a reciprocal in exponent land, you change the sign of the exponent. That's how you make a reciprocal. Did I have a hand up back here? Did I see a hand out the corner of my eye? Michael, did you get? Okay, you want to ask it anyway, just in case someone else might be thinking of it? This thing is the reciprocal of this. So in other words, b to the n is divided by 1. If I want to know what b to the negative n is, it's 1 over b to the n. It's the reciprocal. This is in fraction form. So if b to the n is b to the n divided by 1, in fraction form I invert it. That's what Michael was doing. Derek was doing with his hands, going like this. In fraction form, I just change its sign. Okay, the sign of the exponent. That's like making a reciprocal. So let's take a look now. Let's keep our answer in exponent form because that's where we need our practice, not in fraction form. So if I tell you 2 to the third and I want to know what the reciprocal is, how would you write the reciprocal of 2 to the positive third? Carol? Okay, that's true. But I don't want a fraction. I just want, how would I write the reciprocal of 2 to the third as an exponent? 2 to the what? Negative 3, right. I just changed the sign, right. So notice, I'm just changing the sign of the exponent from positive to negative. Now you say, okay, some of you might still be doing this in your head. Wait a minute, 2 to the third means the same as 2 times 2 times 2, which is 8. The reciprocal of 8 is 1 over 8. So if I had to write 1 over 8, I'd have to write 1 over 2 to the third. And that's the same as saying I have 3 factors of 2. 3 factors of 2, but I'm in the denominator. That's what it means. I'm downstairs. I have a deficit. Okay? I'm in the denominator. I'm in the cellar. I've been bad. They put me in the cellar. All right. Now, without having to go through all that, it's much simpler to say to get the reciprocal of whatever I have here, I just change the sign of the exponent. So I don't want to go through all that in my mind here, think of what the heck is 4 to the negative 2. How would I get the reciprocal of 4 to the negative 2? It's 4 to the what? Positive 2, right? I just changed the sign. 4 to the negative 2 and 4 to the positive 2 are how we write reciprocals in exponent form instead of always changing everything to fractions. You hate fractions, so don't bother with them. Okay? What is the reciprocal of x to the 4th? X to the negative 4. All right, you're getting it because you're starting to get wise with me. I can hear it in your voice. All right, good. Yeah, you went x to the negative 4. I heard you. All right, so we got the idea. Okay? So anything in exponent form, to get its reciprocal, you change the sign of the exponent to the opposite. Whatever you start out with, if your exponent is positive, it becomes negative. If it's negative, it becomes positive. All right, now let's see if we can translate this to a division problem. Okay, we just talked about this a minute ago. If we divide two numbers, it doesn't matter whether the numerator and denominator are fractions or not. If we divide two numbers, you can always change division to its inverse operation, which is multiplication, as long as you change the denominator to its inverse, multiplicative inverse, which is called the reciprocal. So A divided by B is the same as A times the reciprocal of B. We only use this rule when the denominator is a fraction. Otherwise, we don't need it. We just do the division as we normally do. But it applies to any number. So let's take a look at this. No rule. X squared divided by x to the negative 2. This is a division problem. So my division becomes x squared times the reciprocal of the denominator. The reciprocal of x to the negative 2. So it becomes x squared times, what did we just say the reciprocal of x to the negative 2 was? X to the positive 2. So this thing becomes x to the 4th. Oh, that's tricky. We'll take a look at this a couple of different ways. We're just going to practice this way first. Okay, what's our next problem? X to the negative 2 divided by x to the negative 2. What must our answer be when you divide something by itself? Nope, 1. The answer to this has to be 1. So let's do it the longer way. X to the negative 2 times the reciprocal of whatever I'm dividing by. And what am I dividing by? I'm dividing by the reciprocal of x to the negative 2. What is the reciprocal of x to the negative 2? X to the positive 2. When I multiply with the same base, I add my exponents. These are opposite. What do I get? X to the what power? Negative 2 plus 2? 0. And what's x to the 0? 1. And that fits with what we just said a minute ago. Okay. Now we have, these all kind of look the same. They're a little they're playing around with where the x to the negative 2 and x squared is. So this one, I'm not changing this to fractions. Yuck. This says I got x to the negative 2 and I'm dividing it by x to the positive 2. So dividing means I can change it to multiplication times the reciprocal of whatever's in the bottom, the reciprocal of x squared. So the division becomes multiplication, and how do I write the reciprocal of x squared? X to the negative 2. So x to the negative 2 divided by x squared is the same as x to the negative 2 times the reciprocal of whatever sits on bottom. And the reciprocal of x squared is x to the negative 2. I add those two exponents together, and lo and behold, I get x to the what? Negative 4. Okay, so x to the negative 2 divided by x squared becomes x to the negative 4. And unfortunately, we never leave our answers with negative exponents. We have to say what x to the negative 4 is. Hey, I'm the reciprocal of x to the 4th. Okay, so that's how you would leave your answer. Okay, so that's really understanding what's going on. Without changing everything to fractions, you can get all come fumbled up, as my daughter says, come fumbled. She loves to add two words together and make a new word. There's a name for that. Is that called portmanteau? What is that when you take two words and make it into a new word? Yeah, but I thought there was a name for that, like portmanteau. That's a French word. Anyway, all right. So let's go back to this first one here. X squared divided by x to the negative 2. Kind of fooled us. The answer is x to the positive 4. That's what we just said. Multiply it by the reciprocal of the bottom. All right? That's what we just did right here. So let's suppose you didn't think of it that way and you say, I want to go back to the very first page of lecture 19. So let's go back to the very first page of lecture 19. So pull out lecture 19. And on the bottom of the very first page of lecture 19 are all of your exponent rules, right? First law of exponents deals with multiplication. Second law of exponents deals with what? What operation? Division, right? Okay. So what are we doing here? What operation are we doing right here? We're dividing, right? What does it say to do to the exponents when you divide? Subtract them and keep the base the same. What is the base in this problem? Base is x in the top and the base is x in the bottom. They have the same bases, so I can use this exponent property. So I keep my base the same and I subtract my two exponents. My exponent in the top is a positive 2. I'm going to subtract from that the exponent in the bottom, which is what? A negative 2. So I better put that in parentheses so I don't get my two dashes mixed up. And what's 2 take away negative 2 give you? 2 take away negative 2. Math 106, 4, right? Same answer. Just applying the rules of exponents. Now, this is what I see students do. You can do it. I don't advise it because your fractions are weak. But hey, if your fractions are weak, there's one way of making them better. Let's do what we just did right here. But with fractions, your favorite, x squared over x to the negative 2. X squared. How do I write x to the negative 2? I am the reciprocal of x squared. Now that looks like a division problem with fractions. What does dividing x squared by 1 over x squared look like? The same as multiplying by the reciprocal of that, which is x squared over 1. Hey, same exact answer no matter which way I do it. Okay, no matter which way I do it. If you only think about reciprocals as always having to be in fraction form, you're always going to end up with dealing with division of fractions all the time. If you can help your thinking by saying, hey, look, whatever I'm dividing by is multiplying by the reciprocal. And now that I'm in exponent form, all I have to do is take this exponent and change it to its opposite sign. And I'm golden. Or you could say, hey, I don't have to worry about any of that. I can just use the rule on the front of page lecture 19. And I'm all set. 2 take away a negative 2 is x to the 4th. So now you get to practice some of this at your seats. Here you go. All right. So part B here, there's no operation going on in part B. You're not multiplying or dividing anything. It's asking you to rewrite what that means. That's all it's asking you. So this dash becomes a vertical number 1. And then what's left when you take that dash and make it a 1 is 2 to the 3rd. When that goes away and becomes that 1, it's 1 over 2 to the 3rd. So that's a little kind of like visual thing you could do. Okay? So 2 to the negative 3 says, I am the reciprocal of 2 to the 3rd. The reciprocal of 2 to the 3rd. That's all it means. It's the reciprocal. That's it. That's all that little dash means. And you can simplify this and call it 1/8 because you have your perfect squares and cubes and fourths sheet, which is the back page of lecture 19 that you can all refer to. So if you don't have your calculators for your next quiz, make sure you bring that in. So what does this thing say? What is this asking you to do? Huh? 1 over 2, right? It's the reciprocal of, because 2 to the first is just the number 2. It's the reciprocal of 2, which is 1/2. Boom, you're done. Or as Alexander said, 1 over 2 to the first, which is 1/2. Okay? Anytime you raise, this is a nice thing to write in your notes. Anytime you raise a number or a quantity to the -1 power, you're asking to find the reciprocal of the base. So anything raised to the -1 power, anything, it doesn't matter what's inside those parentheses, is 1 over anything. The -1 power is just like my saying to you, take the reciprocal, take the reciprocal. All right, that's all it means. And if it's an exponent form, you can just write 1 over that thing to the positive power. Okay. All right, so D, I purposely, usually I cover this as a lecture, like I lecture to you about this, but I was really curious to see how you did with this. There's multiple approaches to part D. So take the one that works for you. Yeah? Yeah? Yes? Yes. Yeah. When I say there's lots of approaches to this, let me show you at least 3. Okay? And you don't have to know all 3 of them. Take the one that works for you. All right? First of all, would you agree, if you looked at your exponent rules, that I can change -3 to be -1 times 3? Does everybody agree I can change -3 to be -1 times +3? Okay. So when I have something, a power raised to a power, I multiply. So I can change this problem to 2 pieces. I can say, oh, maybe I should change -3 to be -1 and then raise that to the 3rd power, because -1 times 3 is -3. If I do that, I'm performing the reciprocal first. And then I'm going to my second action is to cube it. So let me take the reciprocal of my base. What's the reciprocal of 1/2? What's the reciprocal of 1/2? 2. And now let me cube it. What do I get? 2 cubed. 8. Okay? That's one approach. Do you also agree that -3 is +1 times -3? Okay? So I'm going to do this. 1/2 to the 1st power, and then I'm going to raise it to the -3. Well, you said that's what exactly you have there, so that's nothing new. So that doesn't help me. Doesn't help me at all. So forget that. Okay? So you say, okay, what else could I do? Well, look at your exponent properties. When you have a division problem, what do you do to the power? You distribute it to the top and you distribute it to the bottom. So you have 1 to the -3 over 2 to the -3. Well, what's 1 to any power, regardless of if it's a positive power or a negative power? 1. So I got 1 over 2 to the -3. So this says 1 divided by 2 to the -3 is the same as 1 times the reciprocal of 2 to the -3. And what's the reciprocal of 2 to the -3? 2 to the +3. But look, folks, when you put something under 1, it just says take the reciprocal of 2 to the -3. That's all it means. When you have 1 in the numerator, it says take the reciprocal of the bottom. That's all it does. Just look. One divided by 1/4. How many quarters are in 1? 4. The reciprocal of this. 1 divided by a third. How many thirds are in 1? 3. 4 is the reciprocal of a quarter. 3 is the reciprocal of a third. The answer here is the reciprocal of your denominator. Whenever you have 1 as a numerator, you're just flipping whatever's in the denominator. You're taking the reciprocal. That's another way. Then finally, another way you may not have thought about, but it's kind of cool. Let's look at this. Do you agree that 1/2 is the reciprocal of 2? Is 1/2 the reciprocal of 2? How do I write the reciprocal of 2 in exponent form? 2 to the first is 2. How do I write the reciprocal of 2? In exponent form, not in fraction form. 2 to the what? 2 to the -1. So 1/2 is 2 to the -1. That whole thing's being raised to the -3 power. What do I do when I raise a power to a power? What do I do to my exponents? Multiply them. -1 times -3 is +3. Lots of ways. That's part of the problem with exponents. There's so many ways. I can't show you one way. It's impossible for me to show you one way because I can see it multiple ways. One of these will work for you. Take it. Always use it. You don't have to be flexible. I like to encourage flexibility here, but I want you to find which method works for you. Okay, now, this next one, not much is going on because you have 2 and you're multiplying it by the reciprocal of x cubed. That's what it says. Multiply 2 by the reciprocal of x cubed. 2 times the reciprocal of x cubed is 2 over x cubed. Because 2 is being divided by 1. And when I multiply straight across. Now, what does 1 in the numerator say? Find the what? Find the reciprocal. That's all it says. So this says, find the reciprocal of 3 to the -4th. What's your answer? 3 to the +4. Boom, you're done. That's all it says. I'm not going to change that to a fraction and get involved with, dividing by fractions. Yuck. All that says is find the reciprocal of 3 to the -4. Now let me show you another way that you probably would not have thought of. I want to change this to a division problem with the same base. So my base in the denominator is 3 to the -4. How can I write 1 and have 3 as its base? It would be 3 to what power? That would equal 1. No. 3 to what power will equal the number 1? 0. Okay. Now I have a division problem with the same base. I keep the base the same, and what do I do to my exponents? I subtract them. So 0 take away a -4 is 0 to the 4th, 3 to the 4th. Okay, which is the same exact answer I got here. But it's really cool if all you say is, hey, when I see 1 divided by anything, just take the reciprocal of that anything. All right, it's much easier. Now let's try this. 2 divided by that, it works the same way as the 1 when you have a whole number up there. 2 divided by x to the -3 is the same as 2 times the reciprocal of x to the -3. What's the reciprocal of x to the -3? X to the +3. I'm done. That's it. I'm cool. It's so totally done. Only thing you can do here, addition, none of the exponent rules apply. You can just rewrite it like this. And at the end of the semester, you're going to learn in chapter 5 how to add these. So that's chapter 5. To learn how to add those two. Okay, but now this is multiplication. When you have the same base, what do you do to your exponents? Add them. You don't have to bother changing x to the -4th to 1 over x to the 4th. Just add these two exponents. Why get mixed up in fractions if you don't have to? Now this just says, hey, my exponent's a -1. It just says I'm the reciprocal of x. That's all it says. Now this one, notice, is 4 divided by 8 times c to the -4 divided by c to the -8. 4 divided by 8 is 1/2. C to the -4 divided by c to the -8, a couple of ways you can do it. I keep my numerator the same, Division changes to multiplication by the reciprocal of that. What's the reciprocal of c to the negative 8? C to the positive 8. So I have 1/2 times c to the negative 4 plus 8, which is c to the positive 4. So you can either leave it like that, or you can make it one single fraction and put c to the 4th on top and 2 on the bottom. Half of c to the 4th is the same as c to the 4th divided by 2. How else could you do it? You could use your division rule. You could take this out and say, okay, I have the same base, c. I'm going to subtract my 2 exponents. The exponent in my numerator is a negative 4. I'm going to subtract from that a negative 8. Negative 4 take away a negative 8 is the same as negative 4 plus 8. So that's c to the positive 4. Okay. Now this is a verbal explanation. Is negative 8 a smaller number than negative 4 or a larger number than negative 4? It's smaller because it's further from 0, right? Whenever you subtract a smaller number from a larger number, you have to be positive. So how many spaces are there between negative 4 and negative 8? 4 spaces. That's your answer, c to the 4. Now this one, look, we flipped the whole thing around, folks. Do you see the relationship between j and k? What's the relationship between j and k? They're reciprocals. Perfect. So if my answer to this is c to the 4th, 1/2 c to the 4th, or c to the 4th over 2, it's got to be 2 over c to the 4th. Right, they're reciprocals. That's really cool. Okay. All right, now this one, you have a product raised to a power, so the power attaches itself to each one of those factors inside the parentheses. So this is what I have inside the parentheses, and I'm going to apply my negative 2 exponent to each one. So I get 1 over 4 times x to the positive 6, because when I raise a power to a power, I multiply. You got to know those properties on the bottom of the page, the first page of lecture 19. You've got to know them. There's no way to get through this course without knowing your exponent rules. Okay. Any questions on that? Okay. I'm skipping this. I'm going to go right to scientific notation, because this is where you actually use negative powers. A lot is in scientific notation, and this was very useful in the days when we didn't have calculators and computers. Scientific notation allowed you to either to operate with really large numbers like in astronomy and really small numbers in science, so physics, biology. So on March 4th, 2012, so that was only how many months ago? 7 months ago, right? The US national debt was approximately, has anybody got this amount in their checkbook? So let's see, this is thousands, millions, billions, trillions. 15 billion, trillion, 458 million, 608, oh, no, I'm all screwed up. 15 trillion, 400, all right, you go ahead. I know you deal with numbers like this every day, okay. If you want to see what it is right now, and it's changing every second, you can go to this side. Now, they were talking about this in the debate last week, Romney and Obama. And so rewrite this number using scientific notation. Okay, so scientific notation is your number is between 1 and 10, strictly between 1 and 10. And then you write it by 10 to some power. So if you're taking this huge number and you're going to move the decimal point, which is right here, all the way over, so that you have a number 1.5, right? That's a number between 1 and 10. Then you got to write the whole rest of the number. Oh my God. Times 10 to what power? Well, to make this equal to this, you have to multiply it by a very big power of 10, a very big number. So let's see how many places that 10 is going to be. I move this back to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 times 10 to the 13th. Okay? So that's that number in scientific notation. No, I didn't. Oh, if I asked you, folks, if I asked you to write that number as an approximate in scientific notation, I didn't. I asked you to write what this was equal to. Rewrite the number, so you have to put the whole thing. Here's the number, 58682872114. And I can put the equal sign between those two things. Those two things are equal. Let's go out real quick. Let's go out to that URL. Has anybody got it down, memorized? Let's try it. Let's go out to the URL right here. The debt clause. So what is it? HTTP. Do I have to put the HTTP? I don't think, no. www. You know that, don't you? Debt clock. Okay, let's see what's happening right now. Where is it? Come on. Click here to inquire. I don't want to inquire. This one? This one? That's what I just did. Oh, just put in debt clock? Like that? Oh, I didn't write that. Who says this class isn't fun? All right, there it is. Whoa, baby, look. It's only gone up by approximately $1 trillion. Actually, it's only like 700 and something billion, but look, every single citizen would have to pay this right now. Citizen, not even babies. It's ridiculous. Think about your kids and what it's going to be like for your kids. Maybe some of you are young enough, even what it's going to be like for you when you're as old as I am. It's going to be unbelievable. A lot of things are going to have to change. We just haven't had any politicians yet with the courage to really make the changes. So there we go, folks. Scary, scary business. All right. Now, what about this? We'd have to change this to be 1 times 10. Now, which way are we going now? We got to make this number smaller, so we got to go to the left. We got to divide by a power of 10. How many times? So 1, 2, 3, 4, 5, 6. Okay. Scientific notation. Okay. Okie dokie. So you've got quite a few problems to do right here. I would suggest that you work on the boards, but I probably won't get you to work on the boards. So, what was it? 1 over 10 to the 6? Yeah, 1 divided by, yeah. So get these done and you're free to go. Fly away as birds.